there were a bunch of questions left over from the last session, and I've sort of gone through them. And the first one is from Graham Lowe for John. Shall I read it out? I think I should. Those Taurua hedgehogs, are they pervasive? Is the invasion complete? In the Catlins Beach Forest, they are invading, but they're not established. Perhaps they're not finished with their invasion of New Zealand.
It's a great question, Graham. Thank you. And I don't know, and I don't think there's been a thorough a survey for hedgehogs through all of New Zealand forest areas. And I should have said it was a detail when I had a slide showing that hedgehogs eat 660 grams of food per hectare. That was from one density estimate of hedgehogs in New Zealand, which was by a guy called Chris Berry, who did a master's thesis at Boundary Stream, Mainland Island. And I know that Chris Jones thinks that estimate's probably a bit high. But yeah, as for, I know there probably work about where they are at altitudes, and people are, I think we are used to being not surprised that hedgehogs are way in the middle of forests. But yeah, I would love a more thorough survey, and I can't really answer your question whether they have finished invading the Tauruas or they're at some kind of final distribution. I don't know if does anyone know where the Tier 1 sites look for hedgehogs? Do they put cameras out? Maybe something will come from Doc Tier 1 surveys every 8K across New Zealand.
They turn up in tracking tunnels a bit, so
yeah, it would be interesting to collate it. It's just one of many questions I think that remain for hedgehogs.
Okay, thanks, John. The next one's from Neil Fitzgerald to Joe. Hi, Joe. The increase in possums after rat control is quick. Could there be an element of interference with monitoring devices, chew cards, rats obliterating the possum marks?
That's a good question, Neil. I know that was found by Olivia. Olivia Burge published on that with Dave Kelly and others, that, yeah, you get that lowered detection of possums with ship rats when you're looking at chew cards. But I don't think we had that problem at the study site. We didn't actually have a lot of ship rat engagement with the chew cards. I mean, we had a little bit, but not enough that I think we were dealing with real issues with those chew marks being obliterated. But I agree, it's a very quick response. It's far too quick to be explained by any kind of recruitment, I think. And so potentially it's more a dispersal pattern. Maybe more possums are dispersing into those ship rat controlled sites for some reason.
Okay, thanks, Joe. The next one's also for Joe from Georgina. How many more seeds might have been eaten if they had fallen to the ground rather than being caught in the net?
That's a great question, George. I think probably quite a lot, especially by rats. I'm just going off mainly my PhD fieldwork on Hino, where we had trail cameras on seeds on the ground. And that's where especially ship rats were removing seeds from, but also possums. Possums were more in the canopy, but also a little bit from the ground. So I think that removal could be more substantial, but I guess because our main focus was thinking about food resources for keridu, who we think predominantly will be eating fruit in the canopy, we were more interested in what's happening with those canopy fruits.
Okay, thanks, Joe. You're always a popular girl, Joe, so there's many more questions for you. So one from Francis. Joe, how do you factor out the seeds the birds are eating compared to the rats and possums?
Yeah, that's another very good question. And I was interested because we came from this lens of competition between possums and rats and birds. I was interested to see as well, do we get more seed dispersal at these sites that we're doing these pest control treatments? I didn't expect us to have more birds at those sites because they're very small. I didn't think our pest control would really be increasing bird densities. But I thought, well, if we do actually have more fruits and they're more available for birds, perhaps we'll see that pattern. But I think from a preliminary glance, it didn't really seem like there was more seed dispersal happening. And I guess the issue there could be if the density of frugivorous birds in Tuawhenua forest is still low enough actually that food is not currently limiting. And so, yeah, you're still ending up with fruit crop that just is in the canopy and then falls undispersed. So I think that might be one of the things that's happening.
Okay, still you, Joe. What were the key learnings from co-designing research with Tuhoe Tuawhenua?
That's a great question. I think not just from working with Tūhoe Tuawhenua, but with other iwi partners that I've worked with or are working with, one of the key things that's come out for me is that the real magic happens together. So bringing that local knowledge and the mātauranga Māori from those places and being at place mixed with, you know, us bringing our weird fusty scientific methods that are often more, you know, I guess we're maybe looking at more regional or national levels and we don't understand those nuances or intricacies of those sites. And I think working together with those iwi groups is where you get these really strong, incredible collaborations and real advances in knowledge.
One's for Susan. Hooray! Question for Susan. Great talk, thanks, and a huge amount of work. Interested in how to separate management history from time, how to account for the potential cumulative effects of possum removal from repeat 1080 operations as that ecosystem responds. Microphone, Susan.
Thank you, Graham. Right, this is the magic. We fit BRT models, boosted regression tree models, to the data, and in those models we've got time since the last aerial management operation as a predictor, and we've also got number of previous aerial management operations as a predictor. And so those data, which I interrogated, and are predictions from the model, and we don't have to throw data away. We can actually make predictions and we make them at 7 years after an aerial management operation, and assuming that there were no previous aerial management operations, which sounds a bit weird, but so we clean out those effects which are fitted right across New Zealand and through all years. And so we're ending up with data that are predicted out as if there were no 1080 operations. So if we only relied on the ones that hadn't been managed, we'd be down to quite a small data set altogether and just really wouldn't be able to separate out those noises. So.
Okay, I reckon we can squeeze in one more from an anonymous to Joe. Is it too early to say that prey switching doesn't occur? What kind of study would you like to see to get a more definitive answer?
I guess it's all, I'm a scientist, I'd always say it's too early. We always want to do more research. I guess, sure, we only looked at it at one study site, and the DNA metabarcoding approach gives this stunning level of resolution. It's really fascinating, but it's very short term. You know, you're getting this tiny window into what the rats ate. So I think in retrospect, pairing that approach, this high resolution approach, with something like stable isotopes that can more look at broad scale diet switches over time towards animal protein or so forth, that could have added more strength to the study. It would be really cool to see something like that in future.
Thanks, Joe. Okay, well, that's all the questions we've got time for. I think there's only one more on the list anyway. So,
Kia ora koutou. Ko Angeles Mintokoingwa. I work at Manaki Whenua Land Care Research in Dunedin. And as Graham just noted, I'm not James, so James Griffiths, that is. So I'm just taking over chairing the session for today. And we're going to start off with some questions for Georgia and Adrian. And there was another question that I hope will make sense to you, Adrian. Adrian, have you considered integrating some kind of 3PG modeling, physiological processes predicting growth models, which foresters use to model forest growth? I imagine this might help constrain the upper margins to values based on physiology rather than extrapolated temperature data.
So the answer is yes, but I haven't done it. Like this is something that's been one of those things that's just kind of festering away in the back of my mind. Probably is going to need a Marsden or something to fund it, I think. But yeah, I think it's definitely trying to understand that stuff, and the integration of plant strategies and stuff into the evolutionary strategies and stuff would be really cool.
Cool, awesome. Georgia, I had a question for you, and basically, it's really amazing what you've done with modeling the rat population dynamics. And I was wondering, is it fairly straightforward to kind of, now that you've developed the approach, to take any site and basically also plonk in interactions with other species, like for example, mice?
Yeah, definitely. So the model is currently being used to model both rats and mice. We just haven't added that interaction term in the differential equation model, but it's been done before many times, so it's fairly straightforward to do. As long as we can, it's always the big question with this kind of models is, can we parameterize it right to get the dynamics that we expect? But yes.
Cool. And Adrian, another question for me to just give people a bit more time to think, well, actually to type in their own questions. But obviously there's masting systems in other places as well. Like in Europe, there's beech forests that go through mast events, and you have, those resultant rodent populations and all of those kind of flow-on effects that go, like that cascade through the ecosystem. And I was wondering, do you know if there's any climate signatures in those other masting systems that have been detected that aren't in, I guess, our more sort of oceanic temperate climate?
So there are things going on in those northern temperate forests. Whether they're different to what we're observing here probably depends a lot on these species. Like, I think individual species responses are quite variable, as I kind of showed at the beginning of my talk. So you'd have to kind of actually properly sit down and look at that and say, okay, well, how much of this is kind of a species response versus this is something that's very peculiar to the northern hemisphere. But some of those studies, like in the Mediterranean, droughts and whatnot are really important for seeding and stuff. So the drivers can also be different as well.
Yeah, I guess that's a good point, because I was mostly thinking of that maybe climate change effect might be already more felt, or like just the temperature warming side of things on a continental scale compared to us, where it's sort of the extreme events that also kind of come into play. But
I mean, they also have some longer data sets as well, like that Craigieburn data set's probably the only one that's really long enough in New Zealand to kind of look at that. Our kind of Kainakloa one, is probably getting long enough for that too, but we're not seeing an effect. So whereas in the northern hemisphere, they have some really long data sets, which are great for looking at this sort of thing.
And you touched on a little bit, I guess, in your earlier talk and even now about, I guess, specific site attributes like soil fertility or so on. And with beech, obviously there's that synchronicity with masting, but is that, obviously it must come into play a little bit of, if you're on a really fertile site, that you have more resources, and does that then change the trade-off between seeding and growing?
So my answer to that is, I think yes, but we don't understand it enough yet. So there's some work that's shown a effect of nitrogen, for example, on seeding. The more nitrogen there is available at the site, the higher the masting for beech. But that kind of trade-off at a site, between growth and reproduction and stuff, and how that works along fertility gradients, again, that's something I would love to kind of look at. We've kind of touched on it a little bit with Kainakloa, where all the sites, the species in all the sites in Targay Valley have got quite different fertilities, and you can kind of see that a little bit in terms of the strategies that they use. Like the species that are on infertile sites tend to seed less frequently, but when they do, they just throw everything at it. They just maximally max it out. Whereas those species like Kainakloa ruba, which is on a more fertile site, they tend to seed more frequently, but when they do, they just kind of put a moderate amount of effort into it. So there's definitely stuff going on, but I don't know how it works for beech.
Yeah. No, it's all it's always great to, I guess, at least in that with a lot of avenues for future work, and it definitely seems right to kind of look more at those climate change effects and disentangle it all, and then also understand better how that all cascades through. Right, before starting with the next speakers, I just want to remind everyone, so there's the Q&A function at the top of your screen, and you can just plonk in any question that you have. And then if we don't get to it straight after the speaker, we will try to mop it up usually after a short break, so you have also a bit of time to think about questions. And if we don't get to it, we will still answer your question and send our answers around. And I just saw that there's from Richard Chambers, is this sort of work being done on any of our modified environments, or could it be made to apply, for example, Canterbury Plains Farm or forestry areas? I'm not quite sure, Richard, whether that is around the climate change side of things, I assume with masting species, or if it's around, I guess, rat population dynamics. But yeah, leave it at that for the moment.
Shall I read out? George, you talked about how simulated total seedfall amounts in each year, but how did you translate that yearly amount into daily resource and those resource pulse waves you showed? That makes sense to you?
Yeah, sure. So the total seedfall amounts were produced using Adrian's model, and then because our differential equation model has got a daily time step, what we've done is we have assumed that there was a constant delivery of that seed over the first quarter of the year, and then the amount of available seed decreases because of seedfall decay, as well as the rats eating the seed. So we have two parameters that influence that. There's the maximum per capita feeding rate, and we have a foraging efficiency term. So they both affect how fast that seed goes down throughout the rest of the year when it's not being delivered.
And thanks to everyone who's asked these questions. Dean, are you around? There's quite a few questions for you. Right, so I might start with you, Dean.
Okay.
And Francis Smickel asks, Dean, it looks like snap trappers were much better indicators of density than cameras in the example you used, ?
Yeah, that was just made up data. So don't not based on anything. Sorry about that.
Never trust a scientist. Robert Shadowwinkle asks, excellent and important work. Dean, are you planning to do the same work for mice as well? Or did you already answer that?
No, I didn't.
No?
No plan to do that. I think I think we mice is are the next frontier. Yeah.
Thank you. And from Graham, Dean, do you think food resources might also influence home range size, e.g. resource pulse when density is low causes home ranges to contract?
Yeah, interesting. I would have thought that for possums, but we found that possums that had recently been reduced through 1080 in podocarp forest in the North Island down to low levels had home ranges the size of possums at similar densities in central Otago. There's plenty of food there, but they were looking for conspecifics or whatever. I don't know about mice. I think that's a very interesting question. I think there's not it could be very different.
Thank you. And Anon asks, Dean, what is your feeling? Could we be mistiming management because we are misinterpreting indices as a proxy for density rather than activity?
I think that probably is inevitable occasionally, hopefully not too often. And I think that's sort of the hope that with understanding these indices a bit better, we'll do that less frequently.
And a similar question from John Innes. Dean, do you ever think that the relationships between indices and densities are so vague as to not be useful? Or are you happy at this stage that they are useful and we just need to learn more about how they work?
Yeah, I think they're extremely useful. And I think, Susan, you showed that today. Your work with large numbers that's the point of these indices, is we can put these things out over large areas, do repeat sampling, and when you have lots of data like that, it shows patterns that are very compelling, as you showed. And so I think they're very useful. We just need to understand them better.
Okay, and we've got one from Doug for you. Great explanation of predicting density from indices, but do we have info on relative effectiveness for predictive bird vital rates?
For bird vital rates, no.
Well, that was simple. And Anonymous asks, how important is habitat, e.g. large beech trees, for rat abundance?
Yeah, I think it's the forest that's important. And yeah, so no, I don't have other than the beech forest, I don't have a clear answer for that.
Another one. Hi, Dean. This is the last one for you. With existing tech, cameras at the same placings as tunnels in a tracking tunnel line could help rule out the case of one individual going along the line by looking at the time code and pics. I don't know if anyone does this, though.
Yeah, that would be a good thing, a good test, actually, if you were expecting low density and you wanted to test whether with at a time of low resource availability, whether a few individual rats were seeking out peanut butter down the line.
Thank you. And so I've got a couple of questions to myself. So Andrew Veal asked me, and this is very Andrew Veal, I assume that the map figures wasn't the actual trap lines used, since there are no rats on resolution, or at least they weren't. And he's referring to my picture of Fiordland. And Andrew, that's news to me. Yes, we did use those. There are a few rat tracking tunnels on resolution, and yes, we used those. But they are pretty few. So if indeed we should have excluded them because they're an island and we can't expect any rats there, we will certainly look at that. But I think on balance, they won't have made a huge amount of difference to the results because they were quite few. But thank you for that. That's brilliant. We'll go and peer at them again. And then Caroline asked me, I didn't quite understand why shipwreck numbers increase after aerial management. Can you give a quick explanation? Very quickly, you get this vacuum of rats and mice, or not so much mice, but rats and possums. And so you get food resource sort of building up, or that's what we think happens. And then rats become more abundant than they are in areas that haven't been managed after about a couple of years. And that rat bounce goes for 2 to 3 years after the operation, usually. So that's my quick explanation. Josh, Anon asks you, could rats being predominantly arboreal mean that they are less susceptible to 1080 drops?
Well, it's turn off your speaker, please. Oh, turn off. All right. I suppose it could. Sorry, we just had a bunch of echoes there. I suppose it could. I think perhaps it brings to mind a bit of research on possums and the effect that pre-feeding had on the searching behaviour of possums, and that it kind of trained possums where to find the pre-feed, which was on the ground. So I suspect there's probably a bit of that going on for rats, that when that one of the functions of the pre-feed is to teach the rats that next time they smell a whole lot of cinnamon wafting through the forest, that to go to ground. It's a difficult one to get an answer to, that question, I think.
Okay, thanks, Josh. Anon asked, Josh, it's clear from your research that hungry rats result in better bait effectiveness, but does optimizing rat kill result in the best conservation outcome? Are we falling into the trap of ignoring the phenology, sensitivity of the endemics they are impacting? Hypothetically, e.g. hypothetically, rat kill is maximized post-germination, but potentially endemic A might be driven to local extinction by rat predation when rat numbers are high prior to germination?
Yeah, thanks for that question. It leads quite nicely into my colleague Tristan Rawlins, who's sitting there behind Graham's talk from tomorrow. But that's our challenge, is to work out over time whether or not what we're doing is working. It's reasonably clear that what we've been doing so far isn't always working for the birds that the programs are designed for, is not working spectacularly. And so I guess what we're trying to work out is why that is. It's also pretty clear that effectively controlling rats is difficult, and that there are some times when we go into a mast event, as we did in 2019, after warm into mast periods and going in with pre-elevated rat numbers, that we have some horrendously high, starting from a high base level, we reach much higher end levels, peak levels, and we kind of know that as a high magnitude rat eruption. And it's clear that when you get one of those, that 1080 drop, whether it's during the mast year or post-germination, is not going to be enough because the damage has already been done. And so one of the changes that you'll hear about tomorrow that we're making within the program is that at sites where we really want to hang on to a critical population of a rat-limited species, that we need to be prepared to do more, and that may be a pulse of control before the seed arrives, so that we don't end up in that situation while we're waiting for germination to happen before we go in. So in some of those cases, we're prepared to actually do a pre-seed fall operation and a post-germination operation in order to hang on to those really critical populations.
Thank you, Josh. That's all we've got for you. And there's just one question for James. And that was from me. It was my comment and question. James, that is a very cool hypothesis. And I was talking about your interiors of your areas ending up with more rats, about food resource accumulating or running out. Is this a spatial rat bounce?
It certainly suggests it, Susan, is my response. Yeah.
And so can I do a little follow up there? Do you think that what is happening is that we've actually got, I guess this goes back to Joe's talk this morning, is that as rats sort of surge, they are actually modifying the food resource behind them as well. And so our forests are really controlled, food is controlled by rats as much as it's controlled by, seed fall and that sort of thing in some places.
Well, I think that's a reasonable position to take, and I guess rats are also controlled by the food resource, so it's kind of somewhat circular, isn't it? So it'd be interesting to test it further.
Great, thank you very much.